Is Life with Jason Clemmons, DC. This is Thursday, February 29th, and we are live right here at the Rock Health and Wellness Center studios and on 98.7 Walk by Faith Radio and 1420 AM Lubbock Christian Nation. Hope you guys have had a fantastic day. We have at the Rock. We've had a great day. It's been balanced. We got some things going on. We got some a family member of ours that's not doing well with his health, and everybody's praying for him, hoping that he'll pull through. But things are looking bad, and so we're needing some prayers as far as that goes. But as far as the chiropractic, I will cover that at a later date, and I'll probably have an entire show dedicated to that subject that's going on right there, and we'll see how that works out. And if but when we get there, I'll cover that so everybody knows it has a lot to do with my chiropractic life and the reason that I'm a chiropractor and what I do on a daily basis. Um, but we'll talk about that in a few days or a few weeks or whatever, however things turn out. So we're not going to talk about it tonight. If you guys on social media, you'll have to excuse what I've got so far with the sound that we've got here on the station, and I hope everybody can hear me. That I don't even know. Yeah, I hope that you can hear everything from the show. We've been having some sound troubles in our office, and when we had Chaley on, you can hear everything. Yeah, so it's coming through loud and clear on social media. But yeah, when we had Chaley on this week, we had some feedback going on, and one of the hard things about doing this is that you can't practice it before the show starts because we're live on the radio, and so we can't practice setting up everything and then walking through it and see if it works. We have to try to work on it as we're going through the show, and so that's kind of what happened to us this week on Tuesday. So I'm really looking forward to fixing that problem, getting Chaley back on, and being able to have a good show without any disruption as far as that goes. But I thought tonight, for you guys that are watching the show, I thought I would just bring back my original headset, my original microphone, and get away from my AirPods for a little bit and see if I can fix some of the sound. I hope it's coming through loud and clear for all you guys that are out there in radio land. And I hope everything is coming through for you guys on social media. Blessings, things that we had today that in the office that were just amazing. It the the issue of that I'm dealing with in my family and in my chiropractic life is got me really focused today on the blessings of what I get to do for a living, the blessings of getting to be a chiropractor every single day, the blessings of getting to help people. And so this morning, starting off, just getting to be with people all day long has just it had a renewed blessing. Like if if it wasn't there has to be some things go right in your life to get you to where you want to be in life. And there was a few things that happened to me and when I was a young person that led me to chiropractic, and there was a big influential person in that, and and I was just so thankful today to get to have the opportunity to take care of people. And we had such a vast group of patients that came in today. We had young people, we had old people, we had little babies, we had really old people, we had a young man with a flared up disc in his low back. We have a young lady that's got some nervous system problems that are really bad. Some things that are really affecting her life. We've got some older people with depression. There's just a vast array of people that have come into the office, and I got to see them today. And in this moment of being so appreciative of what I got to do, it was really good to be able to see all those different people and be so thankful for the opportunity to get to take care of so many people. So I wanted to start with that because, one of the things we take care of a lot of we take care of people from all ages, right? But some of our older people, one of the things I was looking up, and I just found this article. It's not scientific, but it comes out of Medical Express. But it says the loneliness. It's talking about loneliness. Loneliness found to increase the risk of health deterioration in older adults. The loneliness often experienced by older people in our society has a negative effect on their physical health, according to researchers from Amsterdam UMC and the University of Glasgow. Um, this epidemiologist at Amsterdam Public Health analyzed research results from more than 130 studies and found that loneliness led to an increase in physical frailty, which in turn increased the risk of adverse health outcomes such as depression, falls, and cognitive decline. These results are published today in the Lancet Healthy Longevity. Recently, and especially during the COVID 19 pandemic, there is more attention to the potential harmful effects of loneliness and social isolation on the health of older people. We wanted to see how far these effects went and saw that all kinds of reduced social functioning, such as loneliness, social isolation, and lack of social support, were associated with physical decline in older adults. Led by Peter Hanlon, clinical research fellow at the University of Glasgow, along with researchers from Amsterdam UMC, Canada, Australia, and Sweden, researchers analyzed the relationship between socially functioning and frailty in older adults, physical frailty. Frailty refers to a lot of different forms of physical deterioration, such as weight loss, reduced walking speed, and decrease in muscle strength. These can all have an effect on, for example, how likely you are to fall. Previous research has already indicated that frailty can lead to a decrease in social contact. In some cases, physical vulnerability can cause people to lose social contact or become lonelier, for example, because they become less mobile. The research shows that this relationship can also be reversed with a decrease in social contact leading to frailty. So, um, being lonely. So why would that lead to depression? Why would being lonely lead to depression? Why would being lonely lead to frailty? Right? Those are some questions that we might want to ask, and we can start that off by, because we know it, you guys know it, the people that are on this show, you guys have heard it lots of different times. The reason that loneliness can lead to depression is because of the lack of stimulation. If you're lonely, you're probably not moving, right? That's one thing that's happening to you. You're probably not moving. And so if you're not moving, then what's happening to your brain, right? You're not firing up into that right side. And where does depression come from? Depression comes from that right side. So and where do we also get on that right side? We get empathy. So this is saying is that we're getting depression because we're not activating that social engagement that we have when we're lonely. So we've said that from the very first time we had a show, that being social is one of the best things that you can do. And what is loneliness? It's the opposite of being social, right? So when we lose that being social with one another, then we lose that right brain stimulation, and then we end up with depression, and that leads down the road. And so when I see these articles, it's like, yeah, it's just another article that supports the idea that yes, that's true. Our brain needs to work properly, and we need to interact with people, and we need to be able to have some empathy towards one another, and that helps the way that our brain functions, right? Also, to be social, you have to go somewhere. If you have to get on your feet, you have to move, you have to go somewhere, you have to walk, you have to those are things that it takes to be social. And so you're basically killing two birds with one stone right there. You're firing your feet and you're firing your right brain, and there goes that's the depression. So being with people is a big deal. Being around people, being social is a big deal. It really does help you in your health. And then another article that I saw, which is something that it's like you see it all the time, and it just is one article after the other, and it's not like we don't know it, and it's not like we haven't talked about it, but this says ultra processed foods linked to heart disease, diabetes, mental disorders, and early death. Study finds eating ultra processed foods raised the risk of developing or dying from dozens of adverse health conditions, according to a new review of 45 meta analysis on almost 10 million people. We found consistent evidence linking higher intakes of ultra processed foods with over 70% of the 45 different health outcomes we assessed, said the senior author Wolfgang Marks, a senior research fellow at the Food and Mood Center at the University of Geelong, Australia. So this comes out of Australia right here. Higher intake was considered about one serving or about 10% more ultra processed foods per day, said the scientist. The scientist in the nutrition and metabolism. Sometimes I can't read. Scientists in the Nutrition and Metabolism branch of the World Health Organization's International Agency for Research on Cancer in an email. This proportion can be regarded as baseline, and for some people consuming more than this baseline, the risk might increase. So there's a study right there. Ultra processed foods linked to heart disease, diabetes, mental disorders, and early death. So I don't think that's something that we want to get into either, right? Whole foods. Whole foods are what we want to eat. We want to eat whole foods. We want to eat grass-fed animals. We want to eat berries more than fruits. We want to eat a little bit of fruit, but we want to eat berries more than fruits. And we want to make sure that we're getting lots of water. And speaking of water, I think I'll have a drink. Got some lemon lime water I've been drinking on this week. It's fantastic. Take one organic lemon, cut it in half, squeeze it in a pitcher of water. Take one lime, cut it in half, squeeze it in half of that lime in a pitcher of water, and tastes great. Don't need anything else. If you don't like water and you can't make yourself drink water, then that's a really easy way to do that. I'm not worried about there's some acidity that goes along with that, but that leads me into my next thought that I wanted to talk about just a little bit, because I want to just kind of study here for a second, and I want to just walk you through some thoughts, and I want you to be able to do this same exact thing, right? So I use DuckDuckGo whenever I'm as my search engine, so it doesn't cut me out of things that I need there. And so I'm looking at why do we become anemic? Because I have a patient, one of my last ones that I adjusted today, she was talking to me about the fact that her mom was talking to me about the fact that she's anemic. And so one of the things I asked her, as I wanted to make sure, is you're not on some sort of proton pump inhibitor, right? You're not taking an antacid or anything like that, right? A Pepsid or a Prevacid or a Nexium, any of that stuff, right? And she's like, no, don't take that, any of that stuff. So you could just Google, and if you look for anemia, and I just went, why do we become anemic? And then I put NIH on the back end of it. And the first one that pops up right there is a study from the NIH. And this is the National Heart, Lung, and Blood Institute. And it takes us to this, and it's like, what causes anemia? Some types of anemias are caused by factors you can't change, like your family history or your age. Yes, okay. Other anemias are caused by factors you can manage, like eating habits and other health conditions that control how your body makes red blood cells. So your age, your blood loss, family history, lifestyle habits. People who do not get nutrients like iron, vitamin B12, and folic acid to make healthy red blood cells have a higher risk of anemia. Drinking too much alcohol also raises your risk of anemia. Well, this little girl's a senior in high school. It's not alcohol is not her problem. Might be your problem. Too much alcohol could be your problem. That might lead you to be anemic. That means that you can't get you don't have enough blood, right? So people who do not get nutrients like iron. Well, I was going back and I was looking at one of my seminars, that I was in with Dr. Fraley, and in one of my notes it says stomach pH of 2 needed to break down iron. You got to have a stomach pH of 2 to break down iron, and that's one of the things right there. The other one was B vitamins, right? So I got this girl some B vitamins today, but if we don't have enough acid in our stomach, then we can start to become anemic. We can start to not we can not break down our iron, and so we got this thing going on where because of pharmaceutical industries, we've got this thing going on that says we we got too much acid in our stomach, right? If we find any esophagus, we got all these new, we got these upper GI tests. I'm going to go get an upper GI and a lower GI, right? And then what happens is the doctors will find they will find some acid in your esophagus, and they'll mention things like esophageal erosion, right? And they'll say to you, well, that's what's you got to be careful. You can't have that much acid in your esophagus. It's going to wear your esophagus out, and that's 100% true. It's 100% true that you will wear your esophagus out if you get in there and you have too much acid in your esophagus. But the question is, why are you having that acid in your esophagus? Why is your body doing that? And so what will happen is you'll go get this upper GI. They'll find some acid in your esophagus. They'll immediately put you on proton pump inhibitors to decrease the acid in your stomach. Well, when you decrease the acid in your stomach, you're creating all kinds of down the line problems. Like it instead of asking the question, why are you having acid in your stomach? Because you have too much acid? Why would that be a case? Like what is it that would cause that right there? Um, and the same thing I have written in the same slide note is H. pylori can't live through a pH of 2. So H. pylori is what is part of that's what causes your ulcers, right? And so if your pH level is not low enough, then you can't break down your iron. So let's just take a look at it and let's ask the old duck duck go and um, what does proton pump inhibitors what do proton pump inhibitors do to your stomach acid? And then I just put the NIH, and that's, or you can put, you can let search the whole thing, right? Um, Here's one from Clinical Lab Medicine. Impact of proton pump inhibitors on the human gastrointestinal microbiome. I don't even know what this is going to say, right? I'm just going to see what they have to say right here. Potent gastric acid suppression using proton pump inhibitors is common in clinical practice, yet may have an important effects on human health that are mediated through changes in the gastrointestinal microbiome. Acting through pH dependent or pH independent mechanisms, proton pump inhibitors have the potential to alter the normal microbiota, although throughout the human gastrointestinal lumen. In the esophagus, proton pump inhibitors change the normal bacteria milieu to decrease distal esophageal exposure to inflammatory gram-negative bacteria, which may lower the risk of Barrett's esophagus. That's what I'm talking about. The proton pump inhibitors may lower the Barrett's esophagus, which is the damage that's done in the esophagus when you get that stomach acid up into the esophagus. The proton in the stomach, the proton pump inhibitor alters the abundance and location of gastric Helicobacter pylori, that's the H. pylori, and other bacteria, which has implications for peptic ulcers disease and gastric malignancies. In the small bowel, proton pump inhibitors cause polymicrobial small bowel bacteria overgrowth and have been associated with the diagnosis of celiac disease. So, okay, we got three separate things right there. We've got, what do proton pump inhibitors do to our esophagus? What do they do to our stomach? And what do they do to our intestines afterwards? Right? Well, they disrupt the pH of the stomach, and and then, and let me talk about that right here. So this says normal gastrointestinal acidity. Acidity within the human gastrointestinal tract varies by anatomic location and is part of essential physiological processes, including digestion and nutrient absorption. In the stomach lumen, pH can approach 1. Gastric acid plays a role in the breakdown of food particles and the pH dependent separation of intrinsic factor from our protein. Outside of the stomach, luminal pH is often discussed in the context of optimizing drug delivery. In general, pH tends to rise gradually from 6.5 in the small bowel to a high of 7.5 um, drop in the cecum, and again rise gradually in the left colon to a high of 6.5 or 7.0. So we've got different tissues throughout our digestion, our gastrointestinal tract, that have to do with the pH changes, right? But in our stomach, we need a low pH, and we do not need a low pH in our esophagus, and we've got to be able to control the acid getting into the esophagus. And how do you do that? So how do we do that? What controls, um, what stops acid from getting into the esophagus? And then let me end it with NIH. See, they're going to go right to gastroesophageal reflux disease. And they're just going to talk about the disease part of it. See what they say about that. I want to just look it up because I want you to be able to look it up, because I understand the mechanism of it. But I just wanted to see if I could find an article that would tell us about why that's happening. Eating habits may also contribute to GERD, right? Risk factors for GERD include older age, excessive body mass index, smoking, anxiety, depression, and less physical activity at work. Why is that? Why would we have anxiety and depression and less physical activity have anything to do with GERD, gastrointestinal um, esophageal reflux disease, right? Eating habits may also contribute to GERD, including the acidity of foods as well as the size and timing of meals, particularly with respect to sleep. Recreational physical activity appears to be protective, except when performed postprandially. Um, it's the primarily a disorder of the lower esophageal sphincter, but there are several factors that may contribute to this development. The factors include are both physiologic and pathologic. The most common cause is transient lower esophageal sphincter relaxations, TLESRS, are brief moments of the lower esophageal sphincter tone inhibition that are independent of a swallow. While they are physiological in nature, there is an increase in the frequency in the postprandial phase that contribute greatly to the acid reflux in patients with GERD. So let's take that right there. Lower esophageal sphincter relaxations, and let's just copy and paste that, and let's take that to another level and see what it will say. And we get into the anatomy of the lower The esophageal sphincter is a bundle of involuntary muscles, muscles that move or contract without you consciously controlling them. The LES sits right where the lower end of your esophagus, the tube that links your mouth to your stomach and connects the stomach. The LES is sometimes called the gastroesophageal sphincter or the gastroesophageal junction because of the two structures it connects. Gastro means stomach, which sometimes referred to as the cardiac sphincter as well because its proximity to the heart. So there's a sphincter that shuts off. There's a group of muscles that's involuntary that closes down, and it keeps the acid from getting up into the esophagus. But you're having trouble with that, the way that gets that closed down, and what it gets reaction. What can cause that? It's the oh, hang on, we're going to a break right here. So I hope you guys will hang on, and we'll be back right after these messages with Life with Jason Clemmons, DC, and we're just breaking down some physiology tonight on Thursday. So hope you guys are enjoying it. Talking about foods, diabetes, mental health disorders, all that sort of thing. You guys stick around. We'll be back right after these messages. So this sphincter. Let me just read this to you. Functional sphincters don't have a thickening ring of muscle like anatomical sphincters do. Instead, they have a circular muscle that works by constricting either around or inside them. This specialized structure can't be visually identified as a sphincter unless it is constricted. When it's relaxed, it looks like the surrounding tissues. So this sphincters are classified as voluntary or involuntary, depending on whether you can activate the sphincter consciously or it is controlled by involuntary muscles. Nerve stimulation for involuntary muscle sphincters comes from autonomic nerves. That's what I was looking for. That's what I was looking for it to say. Stimulate Nerve stimulation from involuntary sphincters come from autonomic nerves, which are part of the autonomic nervous system. It deals with automatic processes, including the function of glands and internal organs. So that's the part I was trying to get at. That I was looking for right there, is I was looking for the autonomic nervous system function in its relationship to acid reflux problems, right? And why we don't want to do that with we don't want to we don't understand that proton pump inhibitors that stop acid from getting into the stomach also change the way that our body processes food below it. And the problem is not that we have too much acid. That's really the big thing that I was trying to share right there. Okay, everybody, we're back. This is Life with Jason Clemmons, DC, and I finally found the piece that I was looking for right there, just so you can read it. So when you get to it, you will know it. The nerve stimulation for involuntary sphincters comes from autonomic nerves, which are part of the autonomic nervous system. It deals with automatic processes, including the function of glands and internal organs. That's what I was trying to get to. We think that if we have acid in our esophagus, then we're going to have um, that we should turn the acid pumps off in our stomach. That's not health. That's not health right there. I'm not talking about medication. I'm not talking about whether you should take it or not. I'm not talking about that. It's not my scope. What I'm talking about is how it is affected, what it does to the nervous system, and that it's part of the nervous system, and that it's part of the way that your brain is functioning. And that's why exercise has been shown to help with exercise has been helps with GERD, with acid reflux disease. Because what is exercise? It's neuro, right? I said that this week to one of my ladies, and I said, "Hey, um, what is the?" I said to her, when she said, well, she said, yeah, I just went to the gym. She's 83 years old. And she said, yeah, I did some cardio in the gym. And I said, you really should change that word to neuro, right? You did some neuro in the gym. And she's like, whatever, I don't care what it's called. And I'm like, I know, but at least you'll think about, if you think about it, you'll think about it from that standpoint and realize that what it actually is it's neurology. You're increasing your neurology when you exercise. You're helping your upper brain turn off your lower brain. You're not getting lower brain escape. You're not getting the vagus nerve involved, which is your autonomic nervous system, to all of your organs. And then that kind of keeps everything calmed down, and you want to have acid in your stomach. So all you people that are taking proton pump inhibitors for esophageal problems, you should think the better option would be to get my nervous system functioning properly. Because if I get my nervous system functioning properly, I can keep the pH level low, and that's what I want. I want that low pH in the acid in my stomach, which helps me break down my iron to make sure that I don't become anemic. Right? It's kind of fun when you put it all together. When you just map it out and you put it all together and you say, hey, yeah, how does this fit together? So the another one I wanted to talk about, and I know that these are things, and we talked about this one just a little bit um, this week. We already talked about it once, but I want to talk about it again because it's something that just keeps coming back up over and over and over again. And this is the idea of what statin drugs do to us, right? And what exactly is happening with us with the statins. And I just want to talk to some of the mechanisms of the statins because I want you to kind of see the what it is and who says what about it, right? And these are some of Dr. Fraley's notes that we went over this weekend again. So this comes from the Journal of the American Medical Association, January 3rd, 1996. Carcinogenity of lipid-lowering drugs. The conclusion: most cholesterol-lowering drugs cause or promote cancer. Patients to whom these drugs are prescribed are exposed throughout many years of doses approaching those shown to be carcinogenic in animals. Now, that's not me. That's coming off of the American Medical Association, January 3rd, 1996, 275, 1, page 55 through 60. That's the Journal of the American Medical Association. Most cholesterol-lowering drugs cause or promote cancer, right? Statin users had both sensory and autonomic submotor fibers reduced in the thigh. Degeneration of the peripheral ganglia may be due to myelin sheath damage of small myelinated fibers caused by the inhibition of HMG-CoA reductase, impairing the conversion of that to um, mevalonate, can't even say that word, which is crucial for the production of cholesterol. Inhibition of ubiquinone, which is through your CoQ10, uh, a key mitochondrial respiratory chain enzyme. Excessive depletion of cholesterol of nerve membranes, induction of necrosis or apoptosis. And there's a big difference. There's a big difference between necrosis and apoptosis. And apoptosis is programmed cell death, and there's some order to the whole thing. Necrosis is just cell death because it ate itself up. It's a bad cell that just kind of it just kind of dissolved, just kind of like an old pair of socks or something that just wears himself out over time. That's more like necrosis, right? So statin use is associated with degeneration of the sensory and autonomic fibers, and that's one of the things that is that we talked about when we talked about the heart rate variability and study, or the heart rate variability stuff that we have in the office. And the heart rate variability is one of my I went over that once today with one of my ladies, and I talked about that with her because um, what we get is the four quadrants, right? And when we're doing heart rate variability, we get the four quadrants, and the four quadrants are this this quadrant one, quadrant two, quadrant three, and really this is, I'm just going to put this as A because it goes before one, because that's really a super fit person that's over there. But this, the way that this is mapped out, if you're over here on this side, what is happening, this is parasympathetic and this is sympathetic. And what's happening is your parasympathetic, which is part of your autonomic nervous system, is starting to fail. Your parasympathetic is starting to fail. And what's keeping you fighting through your day is your sympathetic nervous system. And your sympathetic nervous system, if if it ever fails, then that point is going to go down here, which means you're going to have a decrease in parasympathetic activity and you're going to have a decrease in sympathetic activity. So let's map that back to what I'm saying right here in one of the things that the statins do. Statin use is associated with degeneration of sensory and autonomic fibers. You get degeneration in the sensory and autonomic fibers. You get this degeneration in the sensory and autonomic function, and you start to lose that parasympathetic rest and recover function, and then you move yourself when your adrenal glands give up and you get exhausted, right? And there's an association with it right there. Um, and this comes from association. This is association of statins with sensory and autonomic um, ganglionopathy, front aging neuroscience, 2015. Frontiers on Aging Neuroscience, I guess. That's the article that this came from right here. The pattern of abnormalities, degeneration of proximal while sparing of distal fibers, is consistent with non-length dependent processes with the lesions in the dorsal root and the autonomic ganglia. It's just a part of your nervous system that gets destroyed whenever those statins are involved. And that I was looking for that mevalonate. That was what I was looking for right there, is crucial in the production of cholesterol. And that's what actually happens in the liver, that's trying to make the cholesterol when you block the statins. So I'm sitting in there with this doctor, and we were talking about kind of how the what exactly is going on, and how the um, the pharmaceutical companies will play to the test, right? And so in the liver, you've got a blood vessel. You got a blood vessel mostly inside your gut. You got a blood vessel, and that blood vessel will get a hole in it. It'll get like a little hole in it right there, and it'll start to leak. And so, how are you going to patch up that hole? What you're going to do is you're going to patch it up with cholesterol from the liver. The liver is going to make cholesterol, and it's going to ship it. It's going to ship it out to the blood vessels so that you can patch up the hole. So it's going to get like a little truck. Yeah, not a very good artist, but there's your little truck, and it's going to be your LDL truck. And your LDLs are going to ship the cholesterol to the holes in your blood vessel, and they're gonna patch up the holes. Then you got another little truck, and this truck is your HDL, and it's going to take your HDL truck is going to take this leftover cholesterol, and it's going to put it and haul it back to the liver, and then the liver is going to make bile salts with it, because the liver wants to conserve all that cholesterol, right? So if a person has a healthy blood vessel and they don't have any holes in their blood vessels, then what's going to happen? You're not going to need very much patch. So if you don't have any holes in your blood vessel, you're not going to need very much patch. So you're not going to need to have very many LDLs, and your LDLs are going to go down. But you're going to need to try to salvage as much patch that's out there as possible and bring it back to the liver, because the liver doesn't want to waste anything. So you're going to have to increase your HDLs. So you decrease your LDLs, you increase your HDLs. That's what a healthy person does, right? Well, what happens in with a person that's taking statins? What the statin does inside the liver, and that the statin inside the liver is going to decrease our ability to make cholesterol, because it's going to block that mechanism that I was just saying. That it's going to block the mechanism of HMG CoA to mevalonate. I think I might have got that right this time. So there's the biochemistry of how that processes inside the liver is to decrease the cholesterol. Okay, so now you take the statin, and the statin decreases the cholesterol. Okay, no argument. Well, what does it do to the LDL? It decreases your LDL. What does it do to your HDL? It increases your HDL. It does the same thing that a person would do that was healthy, right? So you go get your blood work, and what does your blood work say after you've taken your statin? It says that you're healthy, right? It says that now, hey, look, now we're back into healthy ranges. But you know what the difference is between the person that takes the statin and the person that's actually healthy? Is the holes in the blood vessel. Because the person that takes the statin didn't address the fact, why was your cholesterol high in the first place? Why did your cholesterol go up? And you know what a pharmaceutical company will tell you? That your cholesterol went up because of Uncle Joe, your grandpa. It was your grandpa's fault, and that's why your cholesterol went up, right? No, your body's smarter than that. Your body was trying to patch up all that hole that you had in your blood vessels because you needed the extra patch, and that's why your cholesterol went up in the first place. That's why your HDL went down, because your HDL will go down if you got all kinds of patch out here. It doesn't take much to get it back, right? So we're sitting in there and we're having this conversation in Dr. Fraley's office, and the DO that's sitting in front of me, who's a sharp dude and military trained and all that sort of thing, right? He's sitting there in front of me and he says, the drug companies know how to make the drug so that it answers the question on the test. They're playing to the test, right? They know that if you take a statin, you decrease your cholesterol. They know that. And they know that you can decrease your LDLs and increase your HDLs. They know that. You guys know it too, because if you're taking one, you know it, right? But the one thing that they don't address is how you patching those holes that were caused from the excess amount of sugar and glucose in the bloodstream, and the damage that's done, the oxidative stress that's done inside the body when the body's not functioning properly. How are you addressing those issues without having any cholesterol? Right? That's the thing that really that starts a whole cascade of things down the road. And CoQ10 is one of them. CoQ10 is one of them that after you take the statin drug, you stop the production of that CoQ10, right? What else is it? Testosterone, estrogen, progesterone, the hormones. And I know we've talked about that a lot of times, but we just don't understand it. I don't think. I think we'll listen to something like this, and we'll let someone break it down for us. So we'll break down the whole pathway of exactly how it happens. We'll break down the mechanism of it. We'll show you the biochemistry of it, and you'll look at it and you'll be like, man, That's the way that works. And you're like, yep, that's the way that works. And then what will you do? You'll go right straight to your doctor. You get your blood work, your cholesterol will be high, and you'll want, they'll say you should probably take a statin. And they're not going to ask you why your cholesterol is high. So you see how the trend goes. See how the trend goes over and over and over again. And it's like you go to the upper GI, you see the acid in the esophagus. The doctor's not wrong. You definitely can decrease the acid in your esophagus if you take a proton pump inhibitor. You can give yourself a little bit of chance to heal your esophagus. While you're doing that, you don't get enough acid to break down your iron. You don't get enough acid to break down your food, and now your food sits in your stomach for a long period of time. And the longer your food sets in your stomach, the more opportunity that your immune system has to get an eyeball on that food. If you're eating it, breaking it down, getting it out, and eliminating it, it doesn't stay in your body very long. So your immune system doesn't have very much time to eyeball it. So you don't get an immune response. But if you decrease your stomach acid, then what's going to happen is you're going to increase the time that the food gets into the body. What does Ozempic do? It decreases gastric emptying, right? It leaves the stomach. It leaves the food in the stomach for longer periods of time. Now the immune system has a chance to eyeball it. When you have a chance to eyeball it, you have a chance to create an immune response. So what are we going to get? Autoimmune diseases. We're going to get a bunch of increased amount of autoimmune diseases because our body is starting to, or we're going to get allergies. We're going to get allergic responses to the food because the food stayed in there too long. All of a sudden, we're allergic to fish. All of a sudden, we're allergic to meat. All of a sudden, we're allergic to eggs. We're allergic to soy. We're allergic to all this stuff, right? And what is it that? Why is it that we're allergic to all these foods? Could it possibly be that we're disrupting our digestive tract by stopping the acid that's in our stomach, right? It's it's just it is it's a battle that we fight every single day. And so let's talk about this little thought right here. And this one's statin induced neuropathy with our gastroparesis, right? Conclusion: long term exposure to statins may substantially increase the risk of polyneuropathy. This was a whole list of statins and risk of polyneuropathy, a case control study in the Journal of Neurology 58, 1333 to 1337. Right? Long term exposure to statins may substantially increase the risk of polyneuropathy because one of the big things that we use cholesterol for is to patch those things, right? But the other thing that we use cholesterol for is to build the cell wall. We have lots of cholesterol in the cell wall. And when we decrease that cholesterol, then we decrease the efficiency of that cell wall. And if that cell wall is around one of our nerves, then we can end up having a problem with the nerves. Or if it's in our blood vessels, we can end up with having problems with our blood vessels. And then we don't get the nutrients to the nerves and we don't get the oxygen to the nerve. And then the nerve ends up where it dies, right? I'm not a fan of statins. And I'm not telling you to take them, and I'm not telling you not to take them, because that's what you should talk to your medical doctor about, whether or not you should take them or not take them. But if we want to talk about health on a 6 o'clock show every night of the week, and we want to talk about health, it's hard to talk about health when a person is taking a medication that's making them unhealthy. We should it's hard for us to achieve health, and it's not any different than bad diet, bad exercise, bad mental outlook on something. It's the same thing. It's chemical stress, right? We talked about that last night. I don't know how many people I had come in today talking about, man, that smoke is wearing me out. I'm having a migraine headache because I think the smoke is setting me off. I've got allergies. My whole head is stopped up, and all this stuff because we got this massive fire. Now, no one's griping in a way that they're not complaining that. I mean, we all have empathy for those people up there that that are dealing with the fire. They're not trying to say that. They're not complaining in that way. They're just trying to say that, man, the smoke is affecting us, right? So if the smoke was affecting us, maybe that would make us understand how those it's hard to be healthy in environments that are incongruent with health. Basically, is kind of what I'm trying to say. It's hard to be healthy when we have an internal environment. It's hard to be healthy when we turn the acid off in our stomach. It's hard to be healthy when we turn the cholesterol off in our liver and we start to break down our cells, and then we start to have problems with our hormones, and we end up with a cortisol problem, right? And that cortisol problem is a whole nother problem which is caused from the stress response. So what would we do about it? What would we do about it if we actually wanted to be healthy? Eat well, move well, and think well, right? If we wanted to be well, we would want to move well, eat well, and think well. And because the alternative is not good. The alternative for us is sickness, and which leads to disease, which leads to death, which leads to really bad things for a lot of people, right? So when we talk about all these things, and I want to, I mean, I probably I could get in trouble. I might get questioned. I don't know if I get in trouble. I might get questioned about talking about this stuff, but I've been doing this long enough to where I'm tired of not talking about it. I'm tired of having people that are getting sick in my life that are not getting talked to about wellness. And I think it's really important that if you're one of those people and you're trying to do wellness, and you're trying to do wellness by taking a statin drug and taking a proton pump inhibitor and taking a blood pressure lowering medication, and you say you're doing a wellness model, you're not doing a wellness model. You're not. That's not what's happening right there. That's not. You can't do a wellness model. You may have lost your ability to function in your environment, and then you have to go with those medications. And if you go with those medications, then God bless you. I'm not throwing stones at you. Not saying that, but I just don't think you should kid yourself. I don't think you could. I don't think you should kid yourself. And there are better alternatives and a better way to get yourself to be healthy. You can actually get yourself to be healthy. I had a patient today that's gone through all kinds of problems. She's been to multiple medical doctors, multiple chiropractors, and they all want to treat her symptoms. They don't want to treat her cause. They don't want to address the cause of the problem. They just want to address the symptom. And I asked her, I said, because she's ready to give up. And I said, don't give up. We just, I don't think you're that bad. I think we can solve this problem if we just address it properly. And she didn't know exactly what properly meant. And so I was like, I think we should start with your brain. We should start working on your brain and get your brain to fire better. And if we can get your brain to fire better, then we can get all that stuff down below to calm itself down. We could desensitize your nervous system and get everything to calm down just a little bit. It's just too active. It's just too active at this point. So, hey, that's all I got for you tonight. I hope you enjoyed that. I hope you guys will come back tomorrow night. We'll be here at 6 live with Jason Clemmons DC live at 6 tomorrow night. You guys have a great evening.